Hello everyone, I am Pushpita Chanda. I am a PhD student at IIT Delhi in the UKLab program. I am TA for today's class. So, the first question is mark all the ODEs that are linear. So here all the ODEs that are linear. So for linear linearity law so for linearity we need to know that the unknown function here, it is y, it should be linear. No nonlinear term of y should be present, like dy dx, it is a derivative of y, it should be linear. d2y dx2, it also should be linear. So y cube, sine y, exponential y, this term should not be present. So the linear means the ordinary differential equation should be linear in terms of dependent parameter or unknown function, which is y. So here we can see that from a glance we can notice that the linear function is, this is not a linear function because it has dy dx whole to the power cube. This function has sine y and this function is y cube. Only this function is linear. This is like a determination by glance or intuition, but if we want to do proper math, then the proper math is that linear function ordinary differentiation equations are the form of L yx is equal to function of x. Here L is a operator. Operator is operating y, which is also a function of x, is equal to a function of x. In the first a, the function is this, is equal to dy dx plus sine x. So the operator which is operating on y is d square d2y dx square minus dy dx is equal to sine x. So here the operator yx is equal to d2 dx2 minus d dx y, which is also function of x. So for the function to be linear or the so we need to follow this rule. Linear operator alpha y1x plus beta y2x must be equal to alpha into linear y1x plus beta y2x. So our operator is L d2 dx2 minus d dx. This is operator. So L the operator on y. alpha y1 plus beta y2, but it will be x d2 dx2 alpha y1 plus beta y2 minus d dx alpha y1 plus beta y2. So here it will be like that, for y1 plus x beta minus d dx alpha y1 minus d dx beta y2. Alpha is a constant, so it will be alpha x d2 dx2 y1 plus beta is constant, so beta into x d2 dx2 y2 minus alpha d dx y1 minus beta d dx y2. So L alpha y1 plus beta y2 would be become of alpha x d will be alpha operator y1 plus beta operator y2. So we can say that operator is a linear, and we have Lyx is linear, and that is a linear ordinary differential equation. Now we will check number B. What will be different for nonlinear ordinary differential equation? Here this is the equation dy dx whole cube. So L y is x d2 y dx square minus dy dx minus dy dx whole cube. Every term containing y should be like in left hand side or treated as operator. Okay, so alpha, it's L y1 plus beta y2. So y will be replaced by alpha y1 plus beta y2. Minus d dx alpha y1 plus beta y2 whole cube. So okay, fine. So from the previous example, we know in this operator it doesn't have any problem. In this operator it will come as alpha into x d2 dx2 y1 plus alpha beta into x d2 dx2 y2 minus alpha d dx y1 minus beta d dx y2. The problem is with this operator. Now we will see if it does give back alpha into d dx y1 whole cube plus beta into d dx y2 whole cube. But we know that wouldn't be possible. It will give a x d2y dx2 minus dy1 dx plus beta x dt d2y2 dx2 minus dy2 dx. In this part, a alpha dy1 dx plus beta dy2 dx whole cube. This part doesn't equal to alpha dy1 dx whole cube plus beta dy2 dx whole cube. This part also contains 3 into alpha into beta dy1 dx a plus b whole cube, a cube plus b cube into 3 into a b a square b a plus b. So that part will be there. So for that reason it is not is equal to, this whole thing is not equal to like a x d2y1 dx square minus dy1 dx minus dy1 dx whole cube plus beta into x square dy1 dx square minus this is 2 dy2 dx plus dy2 dx whole cube. So it is not a linear, Again for part C, the operator is y d2y dx2 minus dy dx minus sine of y. This is operator y. So alpha y1 plus beta y2, alpha y1 plus beta y2 d2 dx2 alpha y1 plus beta y2 minus d by dx alpha y1 plus beta y2 minus sine alpha y1 plus beta y2. So from this we get a term alpha y1 into d2 dx2 alpha y1 plus beta y2 plus beta y2 d2 dx2 alpha y1 plus beta y2. So here we got a term alpha y1 into alpha d2 y1 dx plus alpha y1 beta d2 y2 dx plus beta y1 beta y2 alpha d2 y1 dx plus beta y2 beta d2 y2 dx. Okay, This term will simply give us alpha into dy1 dx plus beta into dy2 dx. Doesn't have any problem, but this term sin A plus sin B, the formula should have to apply, which is sin A cos B plus cos A sin B. So again this whole alpha y1 plus beta y2 will not give alpha linear operator y1 plus beta linear operator y2. This has more term than this. It has extra term, this and this. Even this term contains alpha square. It should not be contain alpha square. So it is not linear.
मैम मुझे आगे दो के क्लास में.
Yes, I was ill, so I could not take class on Saturday. I did take class on Tuesday, and the recording is there. Okay, is it okay? Okay. So let us see what about question number D, which is linear operator. Linear, we should not say linear operator L, which is x d2y dx2 minus dy dx minus y cube. From the first, so it should satisfy this equation. From this part we know there is not gonna any problem. It will give us like in this form, but it will give like third element alpha y1 plus beta y2 whole cube. So it is not equal to alpha y1 whole cube plus beta y2 whole cube. It does contain extra terms. So even D is not linear. Only the option A is linear. Okay, now the second question. Make the ODEs that are second order. Okay, second order, like highest derivative, highest derivative should be second order. Here all have highest derivative of second order. That also and that also, all are true. Third question is find the orthogonal trajectories of the family of curves represented by x is equal to y plus c e y. Okay, so first we need to obtain dy by dx. Here it is given x y plus 1 plus c e to the power y. It is easy to obtain here dx dy rather than dy dx. So first we obtain dx dy, which is, it will be 1 plus c e to the power y. which is y, what, x minus y, because for these orthogonal trajectory problems, when we like obtain slopes, there should be not any constant, so we can write this way. Now we need dy dx, so it will be 1 by x minus y. For orthogonal trajectories of this family curves, say it is m1, m2 will be minus 1 by m1. So for the dy dx, it will be minus y minus x. Okay. Okay, no. It will be minus x minus y, it will be y minus x. Now we need to integrate that. So we can write as dy dx minus y minus x. It can be written as a form dy dx minus p of x into y is equal to qx. Here px is like this. Here px is equal to minus 1 and qx is equal to minus x. So the equation y into e to the power dx is equal to minus x e to the power dx plus c. So this is y e to the power minus x e to the power minus x plus c. For this integration, there is also a constant term, but all those constant terms are taken care of by this c. In this c, all the constant terms are there. Okay. So this derivative will be integration will be integration of integration of v minus du by dx v dx, and this will create how we choose u. So exponential never became u, so it will be minus x e to the power minus dx minus e to the power minus x double integration. Huh? I could ALT what? Where?
Sir, मैम आपने जो लिखा
where? In which slide? This slide?
Last.
This is.
Right side is
Liet. Okay. How can this slide become this? Okay, wait a minute. Yes. Okay. Yeah. This is Liet. Okay, it is Liet. Log trigonometric algebraic log inverse algebraic trigonometric exponential. So how can we choose u? U and gonna be v. So if there is a log, it should be u. If there is no log but inverse, then it should be inverse first, then anything else. V should be anything else. then algebraic, then trigonometric, then exponential. So exponential is the last option. Here x is a algebraic term, it is exponential term. So exponential term will not become u, algebraic term will become u, because a comes first in e. That's I have written. Okay, by some problem. Oof. There is some problem. Please wait us a minute. My system is not responding enough. Okay. So it can be. Payal, is your concern is addressed? Hello.
Yes, ma'am.
Yes.
Yes, ma'am. Okay, now.
Huh?
হ্যাঁ ম্যাম ঠিক আছে।
Okay, okay, okay. P of x into y is equal to qx. So here is this thing. It's not responding. Okay. So here px here px is equal to -1, qx is equal to -x, so y into e to the power -1 dx is equal to, because we know the solution is like this, plus c. So qx minus x e to the power minus dx minus plus c, that will become y e to the power minus x. Here it will be minus x e to the power minus x dx plus c. I already have said that if there is a product of two function u and v, u v minus du by dx become du dx v dx, and we choose u by Liet. So this is y to the power minus x, that can be written x into e to the power minus x dx plus to minus dx plus c. This term will become x e to the power minus x plus one integration, it will be plus, another integration it will be minus, minus minus plus e to the power minus x plus c. So y into e to the power minus x would be x into e to the power minus x plus e to the power minus x plus c. So y is what? X plus, here we need to multiply into e to the power x plus 1 plus c into e to the power x. So the orthogonal trajectories will be of the equation ay is equal to x plus 1 plus c e to the power x. Here they have taken the constant as c1, so the option C is correct. Okay. Please wait a minute because there is some error happening. Okay. Identify all differential equations that are exact differential equation we know are of the form p dx plus if nay they are of the form of like this, where del p del y is equal to del q del x. So the first is three x plus 2y dx plus 2x plus y dy. So this is p. So we should see del p by del y, del y 3x plus 2y. So it will give 2, and this is q. So del q del x, which is del x 2x plus y, which also gives 2. So it is exact. Here only for del y 3x is constant, but 2y is a variable. Only we are doing partial differential equation with respect to y. Here partial differential equation with respect to x. In question B, it is y. Yeah, this is y square plus 3y dx plus 2xy minus 4 dy. So this is p, this is q. Del p del y is 2y plus 3. Del q del x is equal to 2y. Okay. So this is not del p del y is not equal to del q del x, so it is not exact. Question number C, which is 2xy plus y dx plus x square plus 4y dy is equal to 0. It is p, it is q. In some text it can also be written as m x y dx plus n x y dy. Then the rule is del m del y should be is equal to del n by del x, and these exact differential equations have their ways to solve it. So here del p del y 2xy plus y, it is 2x plus 1, and del q del x is equal to del x square plus 4y, which is 2x plus 4. So del p by del y is not equal to del q by del x, not exact. Again, okay, let me give a moment and I will restart the PowerPoint. It is giving so much headache. Okay. Question number D is 6xy plus 2y square minus 5 dx plus 3x square plus 4xy minus 6 dy is equal to 0. This is p, this is q. Del p by del y would be 6x plus 12y. Okay, 12 not, it is 4. And del q by del x will be 6x plus 4y. Here it is del p del y is equal to del q by del x. So D is exact differential equation. So answer is 1 and D. Solve the following differential equation by separating variables. By separating variables means by separate to y. So we need to separate the variables. So we will take xy at the right hand side and take common y, x plus y. Now it is easy to separate the variables. Y dx will be x plus 1 by x dx. So it will be dy by y, 1 plus 1 by x dx. So we will take integration of this. So it will be ln y x plus c. Given the value, if y is equal to, we need to compute if x is equal to 10, it will be the y. So first from this condition we need to obtain c. So it will be ln y is equal to x plus ln x plus c. So when x is equal to 1, y is equal to e. So ln e base e 1 plus ln e 1, okay, is equal to c. It will become 0, it is 1. Or we can write this as a it is minus 1. Basically the 1 minus 1 0, it is 1, so c is equal to 1. So this equation ln y x plus ln x plus 1. So when x is equal to 10, ln y is equal to 10 plus ln 10 plus 1. Or we can write from here that ln y x can be written as ln e to the power x ln x plus ln e. So y is equal to e to the power x into c. So when x is equal to 10, y is equal to e to the power 10 into 10 into c is 1. So 10 into e to the power 10. This term, anything ln e to the power 10, it will give ln e base e is equal to 10. So ln e to the power a would give us a or x. That's why I have written x as like this. So our answer is 10 e to the power 10. Now solve the differential equation giving the initial condition is like this: when x is equal to 0, y is equal to 2, x is equal to 1, y is equal to y1. The root of which of the following equation represents y is y1. Okay, basically we need to compute when x is equal to 1 what is y. So like this kind of differential equation, what you can do, you can take x plus y is equal to z, or x plus y plus 4 is equal to z, or x plus y minus 6 is equal to z. Doesn't matter what gives you a simple calculation, do it. But basically you need to take x plus y is equal to z, because if we derivative x plus y minus 6, the 6 part will give 0 and plus 4 part also gives 0. So here for the simplification I am taking x plus y minus 6 as z. So it will be 1 plus dy dx is equal to dz dx. So dy dx is equal to dz dx minus 1. So putting the value, we get dz dx minus 1 is equal to z plus 10, because minus 6 and there is plus x plus y plus 4, that is. So x plus y minus 6 plus 10 is plus 4. So x plus, that is z, plus 10, here it is z. So we need to simplify that, z plus 10 by z plus 1. So z plus 10 plus z, 2z plus 10z, 2 into z plus 5 by z. Okay, So dz dx to 2 into z plus 5 by z okay, so we need to separate the variable z plus 5 dz to 2 into dx. So we can write this z plus 5 minus 5 by z plus 5 dx dz sorry dx. So it will be dz minus 5 by z plus 5 dz equal to 2 dx. We have to gonna take integration of this. This is will be z minus 5 ln z plus 5, it is 2x plus c. So we the z minus 5 ln z plus 5 is equal to ln x plus c plus okay, not ln x, it's 2x. Okay, so it's z minus 2x minus c is equal to 5 ln z plus 5. Z is equal to x plus y minus 6. So it is x plus y minus 6 minus 2x minus 6 is equal to 5 ln x plus y minus 6 plus 5. So it will become y minus ax minus 6 minus c is equal to 5 ln x plus y minus 1. So when x is equal to 0, y is equal to 2. So it is 2 minus 0 minus 6 minus c is equal to 5 ln 2 minus 1, which is 1 ln 1. So from here we get c is equal to minus 2. So c is equal to 2. C is equal to not minus 2, it is 2. When we put this kind of value, 2 minus 6 minus 4, 5 into minus 5. So that's how it's become 2. Then the equation is 5 of ln x plus y minus 1 is equal to y minus x minus 2. So when x is equal to 1, y is equal to what? y1. So 5 ln y1 plus 1 minus 1 0 is equal to y1 minus 1 minus 2, say y1 minus 3. So it is ln y1 to the power 5 is equal to y1 minus 3. This is the root of the equation. Okay, this is so 2 minus 4 minus 4 minus 6. Okay, it's 2. Solve the differential equation, that is second order differential equation. For this kind of thing we assume y is equal to e to the power mx. So d2y dx square becomes m square e to the power mx. Here there is a question, basic question, why do we assume e to the power mx? Because we need to assume a function which will give the same function after derivation. That's why we assume e to the power mx. Even, and also the sin x and cos x can be written as a function of e to the power mx and e to the power imx, like this. So that's why we take this kind of approach. dy by dx is equal to m e to the power mx. So this equation will become m square e to the power mx plus 8m e to the power mx plus 15 e to the power mx is equal to 0. The equation will become m square plus 8m plus 15 is equal to 0. So it is m plus 3 into m plus 5. When you try to write as a factorial form, it is 0. So m is equal to minus 3 and minus 5. So we can write that the solution is y is equal to c1 e to the power minus 3x plus c2 e to the power minus 5x. To obtain the value of c1, c2, two condition has given. When x is equal to 0, y is equal to 2, and when x is equal to 0, dy by dx is equal to minus 8. So why we know? We need to know dy by dx, which is minus 3c1 e to the power minus 3x minus 5c2 e to the power minus 5x. So here when x is equal to 0, y become 2. So 2 is equal to e to the power 0 is 1, c1 plus c2, and when x is equal to 0, y dash is equal to minus 8. So minus 8 is equal to minus 3c1 minus 5c2. So it will become 3c1 plus 5c2 is equal to 8. So c1 plus c2 is equal to 2, 3c1 plus 5c2 is equal to 8. So after solving this, 3c1 plus 5c2 c2 is equal to okay, it is 8, it is 2, so c2 is equal to 1, so c1 is equal to 1. So y is equal to e to the power minus 3x plus e to the power minus 5. We need to compute the value when x is equal to 1. So when x is equal to 1, y is equal to e to the power minus 3 plus e to the power minus 5. So okay. So mark all the statements that are true, which is a homogeneous function of degree 2. So to know that degree of a function, we fxy is a degree is a function. To know degree of a function, we need to replace x by alpha x and y by alpha y. and here we will get alpha to the power some n function of xy. This n is degree of the function. So we will check for each function one by one. The first one, a x square minus 4xy plus 3y to the power 4x square. It is function of xy. So function of alpha x alpha y will be alpha square x square minus 4 alpha square xy plus 3 alpha to the power 4 y to the power 4 by alpha square x square. We can write it is x square minus 4xy plus, here alpha to the power 4 by alpha square is alpha square, so 3 into y to the power 4 x square. So alpha to the power 2 into function of xy. So it is right, degree of 2. Then second question is b x square y square minus y to the power 4 by x minus 3x square y cos of x y. This is a function of xy. So alpha x alpha y will be alpha to the power 4 x square y square minus alpha to the power 4 y to the power 4 by alpha x minus 3 into alpha square into alpha xy x square for alpha, for x square alpha x to the power square is alpha square and alpha y alpha, and this term will be x by y because alpha x alpha y alpha will cancel out. So we can say it is alpha cube x square y square minus y to the power 4 by x minus 3 into alpha cube x square y cos of xy. So it is alpha cube function of xy. So degree is 3. So it is also right. Question number C, this is function of xy is equal to x square y square minus xy cube ln x by y plus 30 x to the power 5 y. Now we need to compute alpha x alpha y, so it will be alpha to the power 4 x square y square plus alpha to the power 4 x y cube, for y cube alpha cube and 1 x is equal to alpha to the power 1, so alpha to the power 4 again ln it will be x y because alpha x alpha y it will cancel out plus 30 alpha to the power 5 x to the power 5 by alpha y. We can take common alpha to the power 4. So alpha to the power 4 function of xy, it have degree 4. And the last equation is x4 plus y cube. x4 plus y cube are not homogeneous equation. Function of xy is equal to x4 plus y cube. The function of alpha x alpha y, what will happen? Alpha to the power 4 x to the power 4 alpha cube y cube. Here we cannot write as a alpha to the power n function of x y, so it is not homogeneous. Same for x square plus sin y, because alpha x alpha y will become alpha square x square plus sin into alpha y. We cannot write as alpha to the power n f of xy. And also for x square plus 3x plus 1, no, it is function of x y, function of alpha x alpha y is not of a function of alpha to the power n f x y, because here from alpha square x, here, from x will be alpha square x square, it will be alpha x, and it will not have a term containing alpha. So all three functions are not homogeneous, that is also true. So A true, B true, C true, and D is also true. Okay, then again the question number 9 is, let D is equal to dy dx be the differential operator, make all the statements that are true. Wait a minute, I'll continue after that. Okay, so question number is d into d plus x. So we are operating on a function y, so d is d dx, d dx plus x into y, so it is d dx dy dx plus xy. So d2y dx square plus d dx xy, it will become y plus x into d dy dx. So we can write d square plus x into d plus 1 into y. So d into d plus x is equal to d square plus xd plus 1. A is true. Okay, option number B is d cube plus 1. D cube will be d cube by dx cube plus 1 to y. So for this question we will need to come from right hand side to left hand side. So it will be d plus 1 d square minus 2d plus 1 y. So d dx plus 1 into d2 by dx2 minus 2 into d dx plus 1 into y. So first we will operate d square minus 2d plus 1 on y. This will become d square y dx cube and dx square minus 2 into d dy dx plus y. Now we will operate this one by one. D cube y dx cube minus 2 into d square y dx square plus dy dx plus d square y dx square minus, okay, there is not this term 2 minus dy dx plus y, which will give us d cube y dx cube plus y, which is equal to this. So B is true. C is d plus x is equal to d square plus xt plus 1. We have already seen that d square, okay, it is d square xt is given, xt plus we have already seen that it is not equal to, because d into d plus x is equal to d square xt plus 1, so it is not true, so it is right. And last, d plus x minus d minus x, we need to operate it on y, dy dx minus xy, so it will be d2y dx2 minus d dx xy plus x into dy dx minus x square y. So it will be x dy dx minus y plus x dy dx minus x square y. This term and this term will go, so it will be d square y dx square minus x square y minus 1, which is d square minus x square okay minus y. So it is not d square minus x square, so only A and B are true. There is some mistake I have done, it is plus, the first one is minus, minus plus, so it will be minus, it will be minus, it will be plus, okay, no, it will be plus and this is minus, so it will be plus, it is minus, so it will be plus. So d minus plus x into d minus x will be d square minus x square minus 1.
ম্যাম বলছি প্লাস মাইনাসের পজিশনটা চেঞ্জ করলেও কেন অপারেটরের ফাইনাল রেজাল্টটা চেঞ্জ হয়ে যাচ্ছে?
কারণ এই অপারেটরটা লিনিয়ার অপারেটর না, এর জন্যই এই অপারেটরটা, সরি, this operator doesn't follow the algebraic rule a plus b into a minus b, and they don't commute. A b doesn't necessarily equal to ba. So if we take it is a into b, so it not equal to b into a. Okay, operator doesn't follow not always follow the rule of algebraic properties. Understand?
Yes, ma'am.
Okay. Okay, by inspection, guess one solution of the differential equation. Like y, we need to guess the solution of what can be y, right? So the best guess is x. By putting the value of x, we can see if it is 0 or not. Then e to the power x, then sine or cosine. So first x, we will see that x square into 0 plus 1 by x minus x. Okay, dy dx is equal to 1 minus, how can be this, 0, 1 by x dy dx. If y is equal to x, dy dx is 1 minus x. So why does they so e to the power x will not reach near to that. So we will guess that one function is y is e to the power x. Okay, so y1 x is equal to x. We need to find y2. So y2 x we can write is vx into y1 x. So we can write it x into vx. So after differentiating it with respect to x, we will get x dv dx plus v, and double derivative, after taking double derivative, we guess we will get x d square v dx square plus 2 into dv dx. Now we need to substitute this equation. First we know x square d2y dx square plus x. Okay, this equation is not 1 by x, it is x. It is x. That's why when you put y is equal to x, it's gonna give 0. So x into dy dx minus y is equal to 0. So y1 and y2 both will satisfy it. So x square d2y2 dx square plus x dy2 dx minus y2 is 0. We know what is d2y2 dx2 and dy2 dx. So it will become, when we will put that and do the calculation, it will become this 3x square dv dx is equal to 0. So we can write this d square v dx square is equal to minus 3 by x dv dx. So the Wronskian of the equation is dv by dx. So dw dx, we can w stands for Wronskian, but here it is a another variable. W is dv by dx, so dw by dx will be 3xw. The equation will become dw by dx equation number 1 will become this. So dw bw minus 3 by x dx. So ln w will minus 3 ln x. We can take any arbitrary constant, but for the simplicity we will take ln c1. So it will become w is equal to c1, because this is ln x to the power minus 3. So c1 by x cube. And now w is equal to dv by dx, which is c by x cube, v dv c dx by x cube. We will get v is equal to minus c1 to x square plus c2. So y2 will be minus c1 to x square plus c2 into x. Now to obtain the value of c1 and c2, we will apply the conditions. Which condition? When x is equal to 1, y is equal to 2, and when x is equal to 2, y is equal to 5 by 2. So we know yx is equal to y2x minus c1 by 2x square plus c, okay, what is that? Okay, c2 into x. So it will be minus c1 by 2x plus c2x. So when x is equal to 1, y2 is equal to 2. So 2 is equal to minus c1 by 2 plus c2. And when x is equal to 2, y2 is equal to 5 by 2. So 5 by 2 is equal to minus c1 by 4 plus 2c2. From this equation we will get c1 and c2, which is minus 2 and 1. So the y2 will be minus 2 by 2 x plus x. So it will be minus 1 by x plus x. So particular okay, it's minus 2 minus minus plus plus, so it will be that. So y is equal to x plus 1 by x. Those were the assignment question. Now we will solve some question from Boas. Okay, this is some problems from Boas. One is x y dash is equal to y. So x dy dx is equal to y. So it will be dy by y dx by x. So it will be ln y is equal to ln x. For simplicity we take constant and ln c. So it will be ln y is equal to ln x c. So the equation is y is equal to xc. Here condition is given y is equal to 3 when x is equal to 2. So c is equal to y by x, which is 3 by 2. So solution is y is equal to 3 by 2x. The second solution is second question. X root over 1 minus y square dx plus y root over 1 minus x square dx is equal to 0. We need to make x components with dx and y components with dy. So it will be y root over 1 minus x square dx is equal to minus x root over 1 minus y square. Okay, it is dy. It is dy. It will be dx. So y by root over 1 minus y square dy is equal to minus x root over 1 minus x square dx. Take u is equal to 1 minus y square. So du is equal to minus 2y dy, and v is equal to 1 minus x square. So dv is dv is equal to minus 2x dx. So we can write is y dy is equal to minus du by 2 root u is equal to plus dv by 2 root v. We can write is du by root u, dv by root v, and take integration of that. So minus u to the power minus half du is equal to v to the power minus half dv, which will become minus u to the power half v to the power half by half plus c to the by half. So it will be minus u half is equal to v half plus c. U is 1 minus y square. So minus root over 1 minus y square is equal to root over 1 minus x square plus c. So when y is equal to half, y is equal to half when x is equal to half. So x is equal to half, y is equal to half. So root over 1 minus 1 by 4 is equal to root over 1 by 4 plus c. C is equal to minus 2 into 1 minus 1 by 4 root over 3 by 2 is equal to minus root 3. The third equation is y dash sin x. Okay, we can take the name c1. So it is c. So c is equal to c1 by half. So c1 question number 3 is y dash sin x is equal to y ln y. Y dash sin x is equal to y ln y. Y dash is equal to dy dx sin x is equal to y ln y. So dy by y ln y sin, okay, it's dx by sin x. Dy y into ln y is equal to cosec x dx. We can take its integration. So for this part we will take ln y is equal to z. So it will become 1 by y dy is equal to dz. So it will become dz by z, and this is cosec x dx. So the solution is ln z is equal to integration of cosec x give us cosec x minus cot x. For simplicity, we'll take a coefficient ln c. So z equal to cosec x minus cot of x into c. Z is ln y. Okay. Here y is equal to e when x is equal to pi by 3. So y to e, so ln e it will be 1 cosec pi by 3 minus cot pi by 3 is equal to c, it will be 1, and cosec pi by 3 is equal to root 2 by root 3 minus 1 by root 3 to c. So this will become 2 by root 3 minus 1 by root 3. It will become 1 by root 3, which is equal to root 3. So we need to put c is equal to 3. Wait a minute. Okay. Find the orthogonal trajectories of each of the following families of curves. The first curve 31, is x square plus y square is equal to constant. We need to obtain dy by dx. So by derivative 2x dx plus 2y dy, which is equal to 0. So x dx plus y dy is equal to 0. So dy by dx become minus x by y. So it is m1 is equal to minus x by y. The dy dx for orthogonal trajectories will be minus 1 by m1. So it will be y by x. So dy by y dx by x. So ln y is equal to ln x. We can take constant as a ln c. So y is equal to xc. So for orthogonal trajectories of x square plus y square, the solution is y is equal to xc. For 32, y is equal to kx square. So dy dx will be 2kx. So for dy dx for orthogonal trajectory, will be dy by dx okay, here we need to remove k. So k is equal to y by x square into 2 in 2x, so it will be 2 into y by x, so it will be x by 2y, so 2y dy equal to minus x dx. When we take integration of this, it will be 2 into y square by 2 minus x square by 2 plus c. So it will be y square is equal to minus x square by 2 plus c, will be 2y square plus x square is equal to 2c. This is the equation of orthogonal trajectory. But 33, the question number, y is equal to kx to the power n. So it is similar to that. It will be n kx to the power n minus 1. K is equal to y by x to the power n into x to the power n minus 1. It is n y by x. So dy dx for orthogonal trajectory will be minus x and y. So dy will be ny plus x dx is equal to 0. We will take integration of this, so n is equal to y square by 2 plus x square by 2 is equal to c. So it will be ny square plus x square is equal to is equal to 2c. So it is the equation. Okay. Okay. Now these are some differential equation we need to solve, and here we need to take this form as dy by dx plus px into y equal to qx. So the solution of these things is y into e to the power p dx is equal to integration q e to the power integration p dx plus c. So first equation is dy dx plus y is equal to e to the power x. Here px is equal to 1, qx is equal to e to the power x. So e to the power integration px dx will give us e to the power x. So solution for this is y into e to the power x is equal to x e to the power x into e to the power x plus c. So y e to the power x integration e to the power 2x plus c integration of e to the power 2x will be e to the power 2x by 2 plus c. So y is equal to e to the power x by 2 plus c into e to the power minus x. Here there is no condition given, so it is the answer. The second question is x square y dash plus 3xy is equal to 1. We need to write is the standard form. So y dash will be, we need to divide it by x square, so it will be 3 by xy is equal to 1 by x square. Here px is equal to 3 by x and qx is equal to 1 by x square. So e to the power px dx is equal to e to the power 3 by x dx by x, integration is ln x, so e to the power 3 ln x, so we can write is e ln x cube, so it will be x cube. So y into x cube is equal to 1 by x square into x cube plus c, so it is x plus c, so y x cube will be x square by 2 plus c, y is equal to 1 by 2x plus c x cube. This is the answer. The question number 3 is dy plus 2xy minus x e to the power minus x whole square dx is equal to 0. So this dy dx will be x e to the power minus x square minus 2xy. dy by dx plus 2xy is equal to x e to the power minus x square. Here p x is equal to 2x, qx is equal to x e to the power minus x square. So e to the power px dx will be e to the power 2x dx, so it will be e to the power x square. So y into e to the power x square will be x into e to the power minus x square into e to the power x square plus c, which is here there is also a dx. Here is a dx. Which is x dx plus c, so it is x square by 2 plus c. So y is equal to x square by 2 e to the power minus x square plus c e to the power minus x square. This is the solution. So here we need to substitute something in this kind of equations where the in right hand side there is a term containing x and also y. So y dash plus y is equal to x y 2 to the power 3. We will try to separate this thing by dividing y 2 to the power 3 y dash plus y minus 2 to the power 3 into y is equal to x. So it is 1 y 2 to the power 3 dy dash plus y 1 by 3 is equal to x. So if we substitute u is equal to y1 by 3, so du becomes 1 by 3 y1 by 3 minus 1 dy. Okay, so du becomes 1 by 3 y to the power 2 by 3 dy. Now when we substitute this equation becomes 3 du by dx plus u is equal to x. We can write this du by dx plus u by 3 is equal to x by 3. This is a form of u dash plus function of x u is equal to qx. Here px is equal to 1 by 3. So e to the power integration p dx will give us 1 by 3 dx. So e to the power x by 3. So the equation will be e into e to the power x by 3. The x by 3 e to the power x by 3 plus c. So we need to integrate x by 3 e to the power x by 3 dx. So 1 by 3 x e to the power x by 3 dx. Again we will follow the Liet rule. 1 by 3 x to the power x by 3 dx minus x by 3 dx, because d dx is equal to 1. So equal to 1 by 3 x e to the power x by 3 into 1 by 3 minus 1 by 3 e to the power x by 3 dx 1 by 3 whole square e to the power x by 3 dx. So it will be x e to the power x by 3 minus the 3 e to the power x by 3. So u is equal to y to the power 1 by 3 e to the power x by 3 is equal to x e to the power x by 3 minus 3 e to the power x by 3 plus c. This is the answer. For question number 2, the question is y dash by y plus y by x. Hello? Yes? Hello?
নেট রোলটা এর আগে যে একটা কোশ্চেন ছিল সেখানে দি পাওয়ার মাইনাস 8 ছিল।
হ্যাঁ,
আর আপনি একটু আগেই বললেন যে প্রথমে লগারিদমের হবে, তারপরে ইনভার্স যদি থাকে তার। তো এর ক্ষেত্রে আমরা দেখলাম যে ই টু দি পাওয়ার মানে এক্সপোনেনশিয়াল আছে, আবার তার ইনভার্সও আছে। মানে আমরা তাহলে কোনটা
exponent the inverse of exponential is also inverse.
আমরা প্রথমে করব নাকি এক্সপোনেনশিয়াল আছে
Inverse of exponential is also regarded as a exponential. Inverse means sine inverse x, cos inverse x. Inverse means inverse trigonometric functions, not inverse algebraic function also. X to the power minus 3, it's the inverse of 1 by x to the power 3. X to the power minus 3 is 1 by x to the power 3. We can say it is the inverse, but it is not inverse, it is algebraic. Here I means inverse of trigonometric functions. Okay. Okay. E to the power x, e to the power minus x, all are regarded as a exponential function. Y dash plus yx is equal to 2x3 by 2y half. So again here it is y half, divide the both side by y half, so it will be y minus half y dash plus y minus half into y into 1 by x plus 2x3 by 2, 1 by y root y dash plus root y x equal to 2x3 by 2. Now we will substitute root y as u, so du will be half of y to the power minus half du. So this equation will become 2 into du by dx plus 1 by xu is equal to 2x3 by 2. Again similar to the previous question, e to the power px dx, here 1 by x dx, so it is ln x, so e ln ex will become x, so u into x okay, we need to divide the equation by 2. It is du by dx plus 1 by 2xu x 3 by 2. So here is the 2, so half of that, so it will be root x, because half will to follow the logarithmic rule. It is u into root x will be x3 by 2 into x half dx plus c, so it will become 3 4 by 2 x squared dx plus c, which is x cubed by 3 plus c. U is equal to y half, so root y into root x will become x cubed by 3 plus c. Now if we like keep all the y at one side and all the x all side, we can rearrange that. Question number 3 is 3xy square y dash plus 3y cube is equal to 1. So we will divide both side by y. We can write is y cube is equal to 1 by 3. We will divide both side by y square, so it will be y dash plus y square is equal to y by 1 by 3y square. So x dy dx is equal to 1 by 3y square minus y. Okay, we can separate the variables 1 by 3y square minus y dx by x. Now we can write this as a 3y square dy, here 1 minus 3y cube. is equal to ln x plus ln c. So if we take 1 minus 3y cube is equal to z, it will be minus 3 into 3y square dy is equal to dz. So ln x plus ln x into c, we can say that, and it can be written as minus 1 by 3 dz by z. So minus 1 by 3 ln z, so ln z minus 1 by 3. Z is 1 minus 3 cube, 3y cube. So we can write xc is equal to 1 minus 3 y cube to the power minus 1 by 3. Okay, now some second order differential equation, homogeneous second order differential equation. We will learn inhomogeneous second order differential equation later. 2y is equal to 0. Here y should be assumed as y to the power mx. So when we put the value, y dash will be m square plus m minus 2 e to the power mx is equal to 0. So m square plus m minus 2 is equal to 0. That can be written as m square plus 2m minus m minus 2 is equal to 0. So m minus 1, m plus 2 is equal to 0. So m is equal to 1, m is equal to minus 2. So solution, y is equal x to x. Second question is y dash dash minus 4y dash, y dash dash minus 4y dash plus 4y is equal to 0. Again y is equal to e to the power mx for second equation. What? I cannot understand. Huh? You are telling the solution, right? It will be like this, and m minus 2 whole square is equal to 0. As both the root are 2, it will be the solution ax plus b e to the power 2x. Okay, you are saying that? Yeah.
Yes, ma'am.
Yeah, then you have done it right. So question number 3, y dash dash plus 3y is equal to 0. So when y is equal to e to the power mx, the equation will become m square plus x square. What is the question? Okay, 9y. It's not. Nine is equal to 0. So m will be plus minus 3i. For that equation, solution is a e to the power 0 into a, because here when the m is a plus minus ib, we get solution of e to the power ax, a cos of bx plus b sin of bx. But here a is 0, so e to the power 0, a cos of 3x plus b sin of 3x. So it will be a cos of 3x plus b sin 3x.
ম্যাম n equals to a plus minus ib এ লেখা আছে, তাহলে e to the power a কিন্তু ব্র্যাকেটের মধ্যে a cos bx আর শুধুমাত্র প্লাস b sin bx হবে নাকি প্লাস মাইনাস b?
No, it will be plus b sin bx. When we put e to the c1 e to the power m1x plus c2 e to the power m2x, where m1 will be a plus ib and m2 will be a minus ib, and when we will expand it, it will be a cos bx plus b sin bx. Okay.
Okay.
Because okay, let me explain it. Yeah, because e to the power I theta is equal to cos of theta plus I sin theta. Okay, e to the power a plus ib, it can be written as e to the power a into e to the power ib. So e to the power a into cos of b plus I sin of b. Okay, e to the power a minus ib, and there is also x. Okay, x, so x x x x x, so e to the power ibx, it will be e to the power ax cos of bx minus I sin of bx, and there we will write that into e to the power a plus ibx plus c2 e to the power a minus ibx. There will be some coefficients. So after putting all this value, it will come as a plus b sin 3x or plus b sin bx. Okay, so that's all for today.